we're looking at today, this is section 2.3, obviously, of the text. And the names of this data are ogives and frequency polygons. So to reflect back on what we've already learned and what hopefully you still have this on your calculator. And the reason it's nice you still have this on your calculator because, well, one thing, you don't have to re-enter any data and resort it. You've got it all easily available to you. And it's a good reference for all of your classes. You know that if you run your trace utility on the calculator, you get your little cursor bug. You can trace through each class and know how many are in the class and what the class with lower limit and upper limits. Okay, so we're going to really work with these same notions, but we're going to add to them, and the figures that we use for our x-axis are going to change when we create these frequency polygons. So we're just kind of the goal today is just to understand the minutia, the little details of creating these different kind of graphs. So in words here, to construct the frequency polygon, we need this new entry in our table. So when we create our frequency distribution, we're going to add yet another column to the table called the class midpoint. And mathematically, the class midpoint is just the sum of consecutive lower class limits divided by 2. But if we think about what that really means, that's just how you can calculate half the distance. So if I were to add up 670 and 680 and divide by 2, I'm going to inevitably get 675. And then when I do the same with 680 to 690, I'll get 685. So that's a mathematical way of saying half the distance. So if I were to mark this up with class midpoints, they would go strictly between my lower class limits. Okay, and so between 710 and 720, it's 715, and so on. Okay, so we're going to add those to our table, the class midpoint. And then the frequency polygon, it's a bar graph. Instead of a bar graph, it's a line graph. So it uses those points that are connected by line segments. So we lose our buildings, and that represents the frequencies for the classes. Okay, so it's a very simple idea. It's just making sure we understand what the parts are. And the way we construct it is above those class midpoints that we just discussed, we're going to put a point. And on the horizontal axis at the height that matches the frequency of the class. So again, in words, that's what we're doing. If I come back here, we put our 675 and drew it here and put a tick mark here, and we don't need 670 or 680 anymore. We just use the class midpoint. That dot would end up at 2 because that's how many are in this class. So I just put a dot. You can think of it as in the middle of the building, but you have to imagine that that building is not there. It's invisible. And I put all my other points. So this one goes here, point here, right above the class midpoint label. And we'll see that in a minute. Okay, the other thing that's unusual, and you might not guess, is that we're going to draw line segments between all the dots. So it's dot to dot, just like, you know, doing a dot to dot puzzle. But then we're going to add 2 additional line segments, and they're going to tie down the left end and the right end to the horizontal axis. So if we look at our histogram, we don't really have enough room to do that because the place that I tie it down is what would be a midpoint if there were a class that preceded the first useful class. So in this case, that would be 665. So I need a little bit more room here, and I'm going to tie down the line segments. And then on the right side, I need a little more room, and I'm going to tie down the line segments at what would be the next midpoint, 745. All right, so let's cruise on here and take a look at our table updated. So this is the data again for the Old Faithful, and we've got this column added. We're going to do a frequency, so we'll maintain relative frequency, but we're actually going to do frequency for the polygon. And we see the class midpoint is halfway between, or the middle point for each of my classes. Okay, and so now, if I were to layer my frequency polygon graph on top of this histogram, it would look something like this. Notice that 665 doesn't even belong on the histogram, but that's my tie down point on the left side. Then the first class midpoint, I've got a total of 2. I'm a little bit off sync here, but pretty close. And then this has a 0, so it comes back down to the axis, and then 695, and so on. So we're just tying down, doing the dot to dot for the class midpoints and tying down right and left. So if I finally get rid of my reference here from the histogram, this is what your end graph should look like. So this is our frequency polygon. And notice that I no longer have any of my lower class limit markings. Instead, my x-axis only has each of the class midpoints. And then I have an extra one on the right and an extra on the left for my tie downs. And there's what we call the frequency polygon. So kind of a, like I said, it's kind of the minutia to get the job done. And now you know what you're looking at are those class midpoints. And it gives you a different kind of reference or a way to view the data. All right, so that's frequency polygon. And then if we wanted relative frequency, then of course we're just going to adjust the y-axis. And notice that the shapes are identical and the class and the x-axis is identical. We've just changed this to the portion of the whole for each of these classes. All right, so that's one. This next one that we call the ogive is a cumulative frequency and or cumulative relative frequency. So in words, cumulative frequency, it's going to aggregate the frequency of each category. So we never lose, we never go back down. So we accumulate from class to class as we go. So it's going to be the total number of observations less than or equal to the current class or category. So you can see that that's a increasing function, so to speak. For continuous data, then it's the same idea. So it's the observations less than or equal to the upper class limit of a class. And then the cumulative relative frequency is going to tally up the relative frequencies. Okay, so in a nutshell, by the time you've gotten to the last class or the last category for your numeric data, the reference point on the y-axis should be equal to the number of values in your data set. So how many eruptions did we have total? Where'd our table go? Okay, we had a total of, I forget now, I have to add this up, 18, 6, 45 eruptions. So that would mean that by the time we get to the top here, we'll hit 45. And by the time we get to the top on the relative frequency, since 100% of the data is accounted for, we're going to hit a 1 or a 100%, depending on how we've labeled our y-axis. Okay, so I know it's a little tricky in words to kind of figure out everything that's going on. So now we'll get a little bit of a picture of it. Now we're going to do the upfront work to create the table and create a new column for both cumulative frequency and cumulative relative frequency. Okay, so all that's happening here, let's see. Okay, so my first frequency is 2, and so is my cumulative frequency because I'm in my first class. In my second class, I've added 0 more, so there's the frequency. So when I add those two together, I'm still at 2. But now accumulating the data, I have to add all the columns of frequency. So these all add up and go over here into my cumulative frequency. So now I've got the 2 I've built up plus 7 more for a cumulative total of 9. And then from these 9, I've added 9 more at the next class. And now my total is 18 and so on. So that now you can see why when I get to the last class, I've added the last amount. So I've tallied up all my frequencies cumulatively per class, and now I end up with a grand total of 45. And so that same notion carries over for cumulative relative frequency. This is 0.0444, or you could say 4.44%, however you like to think of it, 2 out of 45. And then since I added no more here, I've still just got 2 out of 45, but now I've got a total of 9 out of 45, and that's 20%. And then I've got a total of 18, so that's 40%. So I'm accumulating the frequencies, and then you can see that by the time I get to the last and final class, I've got all 45 because I've added the last 7 that were left here, and 100% or 1.0. So these are going to represent the y-axis, either cumulative frequency or cumulative relative frequency will be our new y-axis. Now, what's going to take us for a little bit of a throw here is that we've got to label our x-axis differently than we ever have before either. So we're not going to use lower class limits. We're not going to use class midpoints. And and the name of this, we call it an ogive. And so it's just a cumulative frequency or cumulative relative frequency. And in words, how we'll do it is we'll plot points whose x coordinate are the upper class limits. Okay, so the x coordinate are, isn't that weird? We haven't used upper class limits at all. So to refresh you on that, this is what I'm going to label my graph with on the x-axis, upper class limits. Okay. Weird, huh? Okay, so we're going to do the same thing, though. We're going to draw line segments that connect consecutive points, and we're going to do a tie down on the left. So tie down. Okay, not on the right. And we'll do it by locating an upper limit that would precede the first class if it existed. Okay, so going back to our table, if I had an upper limit that would precede the upper limit of 679, it would be 669. So that's my tie down. Tie at 669, and we don't, no tie here at the end. So it just ends up at the top here. But we're going to tie down in the front. All right, so this will, hopefully all this will come together when you see the actual graph. Okay, so reflecting back on our table, remember that the cumulative frequency, and you can see why it's a increasing function in the sense that, so here's my tie down on the left, ties it to the x-axis. This is not an actual upper class limit. Here's my first upper class limit. And at that point, I had a tally of 2. Remember that second class was 0, so we added no more. So by the end of the second class, we're still at only 2. By the end of the third class, we added those 7 more, I think. So now we're at 9. And then however many more we're adding from class to class is the amount between here and here, point to point. So obviously, by the time we get to the end, here's my upper class limit of the UCL of last class. So by the time I get there, I'm at my 45 total frequency of eruption data. And there's our ogive. So it kind of tells you the steepness. So it reflects different things about the data that you're looking at. And unfortunately, we don't have a lot of critical analysis of this, but you can see that what's reflected here, well, obviously, you know, from a class to a class, this tells you this is a very inactive period. And if it shoots up really steep, then it's a very active period and things like that that you can tell. Okay, so we call that a frequency ogive. And here's the relative frequency version. So same x-axis data, imaginary upper class limit, actual upper class limits to the end. Frequencies are accumulated as we go until we reach 100% or the top. Okay, and again, it's up to you whether you want to label this with percentages and this be 100 or with decimals and this be a 1.